Hey pre-16 students, here are a couple more examples of graphing trig functions like sine and cosine with phase shifts. So for this function, which is y equal to 3 times sine of 3 halves x minus 3 pi over 4, we have to look at kind of all the pieces. So first of all, the amplitude is 3. The vertical shift is none, right? There's no plus or minus anything out here. The period is 2 pi divided by the coefficient of x, which is 3 halves, which is 2 pi times 2 thirds, which is 4 pi over 3. Let's close the door. And then finally the phase shift. I'm leave myself some room here. The phase shift we find by setting whatever's inside the trig function equal to 0. So it's not 3 pi over 4 to the right. It's going to be, let's see, 3 halves x minus 3 pi over 4 equal to 0. 3 halves x equals 3 pi over 4. Multiply both sides by 2 thirds to get x equal to 3 pi over 4 times 2 thirds. Cancel a 3, cancel a 2, and you get pi over 2. So this graph is going to be shifted pi over 2 to the right. Which makes sense, because if you plug in pi over 2 for x, you get sine of 0. And you want to start when the angle, which is all this, is 0. So we know our graph is going to start at pi over 2. And our period is going to be 4 pi over 3. So 4 pi over 3 later, which is like a whole pi in the third, we're going to end the thing. Now what I really want to do is I want to break that up into 4 equal quarters. So I'm going to take my period, and I'm going to find 1/4 of my period. So 1/4 of my period is 1/4 times 4 pi over 3. Here it's real easy, the 4's cancel and you get pi over 3. So each of these sections here, and pi over 3 is a little bit smaller than pi over 3, so I'm going to make this a little bit larger. I'm going to say that pi over 2 is maybe more like over here. And each of the quarters are going to be each of these lengths. I feel like I didn't make that look very nice. Let me make that look a little bit smaller. Sorry. So that's pi over 2. Pi over 3 is like that much. So maybe like that much. Okay. So like there, 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 and there. Over here is going to be pi over 2 plus a whole period, which is 4 pi over 3. So this whole length, which I'm going to kind of draw like this. Not that you have to do this, but I just want to show you, right? This whole length is going to be 4 pi over 3. And each of these quarters is going to be 1/4 of the period, which is pi over 3. So this point right here is going to be pi over 2 plus pi over 3. So the way I typically find that is I have to say, okay, the first point is pi over 2. The next point, which I call x sub 2, is pi over 2 plus pi over 3. Pi over 2 is 3 pi over 6. Pi over 3 is 2 pi over 6. So that's 3 pi over 6 plus 2 pi over 6, which is 5 pi over 6. That's this point here. The next point is the previous point plus another pi over 3, which is 2 pi over 6. So I get 7 pi over 6. So that's the next point, which is 7 pi over 6. Then the next one, we're going to add 2 pi over 6 again. So x4 is going to be 7 pi over 6 plus 2 pi over 6, which is 9 pi over 6. I'm not reducing. And the last point is going to be the previous point plus another 2 pi over 6, which is 11 pi over 6. And you look at the difference between 11 pi over 6 and pi over 2. 11 pi over 6 minus pi over 2, which is 3 pi over 6, is 8 pi over 6, which is 4 pi over 3, which is exactly how long the period is. So from the first point to the last point, the distance should be the whole period. All right, so now we want to graph 3 sine of this. So sine goes, right, there's no vertical shift. So the amplitude is just going to take us as high as 3 and as low as -3. Because our middle line is 0 since there isn't a vertical shift. So sine starts at 0 at the first important point, or first important axis, and then the next one goes up to the top, and back to the middle, then down to the bottom, then back to the middle. So it looks like this. Now, of course, there's more to the left, right? Like it does that. So I would encourage you, if you have the time, to graph this on Desmos and compare it to how it looks here, from pi over 2 to 11 pi over 6. Let's do one more. So now we're going to graph 2 cosine of 2/3 x plus pi over 6 plus 1. So this is going to have a vertical shift up 1, an amplitude of 2. So without a vertical shift, normally an amplitude of 2 would take you as high as 2 and as low as negative 2. Now we're going to shift that up 1, so we're going to go as high as 2 plus 1, which is 3, and as low as negative 2 plus 1, which is negative 1. We have a period that is 2 pi divided by 2/3. I feel like that's the same one I did before. No, it's not. 2 pi divided by 2/3 is equal to 2 pi times 3 halves. The 2's cancel, and I get a period that is 3 pi. Pi times 3. All right, let's find our phase shift or horizontal shift. We're going to get that by setting what's inside the trig function equal to 0. So 2/3 x plus pi over 6 equals 0. I'm just going to bring this over, but change the sign. So 2/3 x equals negative pi over 6. Multiply both sides by 3 halves, and this would be pi over 6. So x equals negative pi over 6 times 3 over 2, which reduces down to negative pi over 4. Or negative 3 pi over 12, which is negative pi over 4. So it's going to be pi over 4 to the left. So I'm going to start graphing this. Let's see, I'm going to give myself enough room here, sure. So it's going to start at pi over 4 to the left. And we know that we have a new midline of up 1. It's going to be like right about there-ish. Again, my numbers are, my graph is usually not super precise. And then we know we're going to go 1, 2 above at 3, and 1, 2 below at negative 1. Okay. And then we need to find our 5 important x values. We already got the first one. The first one is x sub 1 equal to negative pi over 4. Oh, we need 1/4 of our period to know how far each of our x values are apart, right? So our period, or 1/4 of our period, is equal to 1/4 of negative pi over 4. No, sorry, that's not my period. It's equal to 1/4 of 3 pi, which is just 3 pi over 4. So to get my next important x value, it's going to be, right, I'm going to have 4 quarter periods. I'm going to have one of those and one of those. I don't think I drew it big enough. I'm going to kind of try to squeeze it in. Sure, that'll be fine. So if I add, right, so this is 1/4 of a period length. So I'm going to do negative pi over 4 plus 1/4 of my period to get the next value. Negative pi over 4 plus 3 pi over 4. We have to be lucky here that the denominators are the same. We just get 2 pi over 4. So that's going to be 2 pi over 4 right there. And then to get the next one, so 1, 2, the third one, I'm going to have this one, 2 pi over 4, plus another quarter of the whole period, which is 3 pi over 4, which gives me 5 pi over 4. To get the next one, I take my previous one, add another quarter of a period to get 5 pi over 4 plus 8 pi plus 3 pi over 4 is 8 pi over 4. Again, I know I'm not reducing any of these, that's just 2 pi. If I'm writing 8 pi over 4. Because then it's easy to get the next one if I leave it like this. The last one is going to be the previous one, 8 pi over 4, plus another quarter of a period, which is 3 pi over 4, to give me 11 pi over 4. And if you look at the difference from the first one to the last one, 11 pi over 4 minus negative pi over 4 is 11 pi over 4 plus pi over 4, which is 12 pi over 4, which is equal to 3 pi, which is the period. So always from here to here should be exactly 1 full period. All right, then cosine starts not in the middle, not at the bottom, but at the top. So at the first x value, we start at the highest y value, which is 3. And then at the next point, which is over here, we're at the middle line, so we're right there, right? There's no particular y intercept we care about. Hopefully my thing is still recording. My screensaver just went off for a second. And then at the next important x, we're going to be the lowest point. So this thing I've written is kind of in the way. Let's just erase that for a minute. We'll rewrite it. So this is 5 pi over 4. And at the next point, we're back at the middle. At the next important next point, we're back at the top. So we started at the top, we went down 2 to the middle, we went down 2 to the bottom, 2 up to the middle, 2 up to the top. It's going to look like this. Mine's not going to look perfect ever, really. But in this case especially, all of these should be equally spaced out, and this one looks like it's a little bit longer, so not a big deal. But that's how we graph things like this.